Hello, community. Let's talk about the latest when AI does science. So, wouldn't this be great? We have an artificial intelligence here solving the most important problems that we have from biology, cancer research, everything. So, what is holding us back? Let's discover here the latest AI research, and I record this on September 11, 2025. We have a beautiful new study. Look at this. This is here by University of Oxford, University of Cambridge, Princeton University, Stanford University, OpenAI, New York University, University of Michigan, and beautiful. And it's about measuring and mitigating the overreliance is necessary for building here a true human-compatible AI system. So you might say, this is strange. All these famous institutions, inclusive OpenAI, now try to find the best human-compatible AI? Absolutely. And here we have the second paper we're going to have a look at. This is from Carnegie Mellon University, published September 10th, 2025. The more you automate science, the less you will see. And they talk about the hidden pitfalls of AI scientist systems, exactly what we are focusing. Plus, we have a new study here by ByteDance. This is here Fudan University, ByteDance Seed, and Shanghai Innovation Institute about agent GEM reinforcement learning. So training LLM agents here for long horizon decision making through a multi-turn reinforcement learning. If we have time, we will look at a new publication from the US Air Force and MIT about here accelerating AI development with cyber arenas. This is an absolute interesting topic here. And yes, as you see, this is here focused here on military capabilities. And I also have some learning resources for you if you're interested to have a deep dive. At first, today was published here a new survey of reinforcement learning for large reasoning models. This is here beautiful. This is from Tsinghua University, Shanghai AI Laboratory, Peking University, also University of Washington, University College London, and a lot of other beautiful, highly intelligent people. This of 114 pages, and they give you here an absolute perfect overview over all the reinforcement learning methodologies we have today. And of course, I would like to mention here the super intelligence team by Meta. And they also came out here just yesterday, September 9th, and they told us here, you know what? We have now a new idea that our LLMs just self-play in a data-free training mode to continue to learn. So they take the idea that I showed you here from MIT and Harvard, where they say code is for machines only, not for humans. And they have here a code, a scientific game like AlphaGo. But now here, as you see, Meta Superintelligence takes this a step further and says, our LLMs, we don't need data for the training of LLMs. The LLMs should play with itself. Maybe this is not really what I would recommend, but this is a new paper by Meta Superintelligence. So you see, these are the paper we're going to talk about. Have a look, read the paper, please yourself. They're absolutely fascinating. This is the current state of AI today. Let's start. And we start here, as I showed you, the collaboration between an AI system in science with a human. And now we find out it is not what we thought, how we have to program an AI system, because then we just get errors. There's a new way to build this cooperation. And here, from Oxford, Cambridge, Princeton, OpenAI, Harvard University, everybody's telling us we have to do it differently. So let's have a look. They especially mention here healthcare, and they say, you know what? If we do have an over-reliance on humans, on the result of AI, let's have a look. What are the consequences? Now, individually, if you have a medical doctor that follows here some incorrect AI diagnosis, this can have some severe effects. Or if you have here look for healthcare professionals that experience here cognitive de-skilling and an atrophy of diagnostic abilities because they don't start to think themselves, they just rely what the AI tells them. So this means hospital systems now implement also AI diagnostics, but it could be dangerous if it's done without an adequate verification protocols so that the statements by the AI are verified multiple times. because medical departments restructure currently workflows around this AI system. They focus on the integration of AI systems because they are so cheap. No, you don't have to pay these expensive human doctors, therefore reducing also the human oversight. And maybe this is not what you want as a patient. And we will not look here at the perspective here of a hospital administrative financial officer. Or they say, let's take another segment. Let's take personal advice. No, I don't know how many billion users OpenAI has per day, but there are some problems. No, on the individual level, user accepts here a sycophantic or a biased relationship advice without any critical evaluation what the AI tells it. The AI has maybe no idea who you are, what are your conditions, where you are living, what you already have experienced in your life. Maybe it is just here some general advice. And you know what's critical? Then the self-worth of maybe young people becomes derived here from the AI companion approval. The approval of the machine will have an influence on the self-worth of young people. And I can tell you, I'm not a young people, but also, if AI agrees with me, it feels good. If AI is here and having critique, I say, what have I done wrong? If you look at this on a societal level, communities adapt similar AI-generated advice, creating a much more homogeneous decision pattern. So everything becomes flat. We don't have this beautiful multi-voice, everybody has a different opinion and we have to discuss and argue. But if we just accept what AI-generated advice is, and everybody says, okay, I just go with this, we will just become flat. So this is not just on singular persons or on communities, on groups. This is also that the complete societal norms shift now towards an algorithmic validation of personal choices. So these are now some dangerous elements we could face if we implement here AI in the future in the wrong way. And they say, the authors of the study, hey, a critical failure mode in the human-AI interface is the human over-reliance on the output of an AI. And they really said, let's focus on this. And it is absolutely ensuring that these powerful AI systems augment rather than undermine here the human intelligence and the autonomy. And they say the over-reliance that humans have is a direct threat to this particular goal. And it represents here a fundamental misalignment, yes, of course, reinforcement learning, between the AI's apparent competence and its actual reliability, leading to tangible harms. So you see, all those institutions and all those people say, listen, we have to do something for the future. We have to innovate in system design. We have to build better AI interfaces and interaction patterns that promote much more the critical thinking aspect and some appropriate trust calibration. This is currently totally missing. And the authors tell us, you know what, we have to define and refine the model training of our AIs, our reinforcement learning. We have to improve this. And the authors tell us we have to develop AI training protocols that go beyond the classical reinforcement learning or the reinforcement learning by human feedback, that teach here the AI models to communicate their limitations and their uncertainties to the human effectively. And this is currently missing in our AI systems. And the authors define now this human over-reliance as a human behavior. And they say, we have to think about. The other term, the technical term if you want, is trust. A psychological state of willingness to be vulnerable. And an over-reliance is a behavioral consequence of excessive or misplaced trust that humans have in those AI machines. And on the other side, we have the term over-dependence. So this means relying on a system more frequently than necessary. Why we don't use our human brains for 99% of the task. So over-reliance can lead to an over-dependence on AI system over time. And I thought at first, this is not concerning me at all, but it is a fascinating study. Have a look at this. And they even built a taxonomy of risks, of human risk if you don't change AI. And you know this example, no? A lawyer uses here LLM to write a legal brief, or a developer simply accepts an AI-generated code, but there are inherent security vulnerabilities. Or when multiple organizations, let's say in finance, Wall Street, rely on the same flawed LLM. So you have a single vulnerability in a single large language model. This can cause cascading failures in a complete industrial sector. Or as more content and ideas are generated with AI assistant, and maybe I should integrate with only AI guidance, the human thought and expression may converge now towards these AI ideas. And researchers found that LLM-assisted writers produce less diverse ideas. They just follow the ideas of the AI machine. And they say over time, this culture flattening of the complete society, of the complete branch, or of the complete, if you want, market segment, could here really stifle innovation and homogenize a discourse. And they say, okay, what can we do? We can talk about the model itself, we can talk about the system design overall, and then we have to go to the weakest component, the user's cognition. So let's have a look at first at the model's characteristic. And the authors tell us, the very nature how we code LLM today makes them potent drivers of overreliance, because we want our LLMs to be experts, no? So they behave here with a kind of an expert mimicry. They use fluent, emphatic, and confident language. They can structure text with citations, and even if they're hallucinated or faked or whatever, and adopt here an assertive tone, creating here an illusion of universal competence. And especially against young people, there is an inherent danger. And models are often trained here, especially with reinforcement learnings, to be agreeable. This is also here something that a human tendency exists. And of course, LLMs have no idea how bad they are at knowing what they do not know. They just present you hallucination with an absolute high confidence as a factual statement. And they're absolutely wrong. And we humans, we tend to believe them without thinking about it ourselves. So let's talk about the system design. What are critical points here? Most human AI interfaces don't visually represent here the model uncertainty. Now, I have just seen yesterday a brand new LLM where they said for each word, we color code each word. Green, the AI is absolutely certain that this is the correct word. And red, if this is maybe a hallucination or something that has a very low degree of, where you will say, this is the correct term. So there are already some prototypes here out in the world. Yeah? And the user cognition, of course, is here the human component. Yeah? Because we as humans, we are simply susceptible to automation bias. No? A tendency to over-trust here an answer given by an automated AI system, especially if we are under heavy cognitive load. If we have a deadline to perform here, a test, or, deliver something. Human cognition is computationally bounded. I've never read that sentence before, no? But yeah, of course, when faced with a complex task and a limited amount of time, we just accept almost everything that is given to us by the machine. No? We default to the path of least cognitive effort. Just copy what the AI said, but this is often uncritically accepting here the AI output, and therefore this is not the way to go forward between the human AI interface. No? And users often form here a mental model of an LLM capabilities based on just a few interactions. No? You have a look at the model at the first time and say, hey, this is great, unbelievable. No? And then you just believe the model can do everything in every domain at every complexity level. And there's a dangerously overgeneralized belief now in the humans that those model abilities are working across all domains, and this is an all-knowing element. So all this old paradigm that we thought that we know and we have implemented here for the machines, now all this fails now for large language models, and they say here for three fundamental reasons. And they said the interaction that we have as a human with an LLM is not a single point interaction. No? It is a dialogue, an iterative dialogue. The user and the AI co-create the output. I discuss with my AI a lot of. So therefore, it is nearly impossible to disentangle here the AI influence from the user's own ideation, making here the advice acceptance a meaningless context. We have just intermingled AI ideas and human ideas. And plus, we don't only work in mathematics or theoretical physics. No, we have tasks like creative writing or receiving some personal advice. No? So there is no ground truth to determine if the output is correct or incorrect. This is just an interpretation, and we humans, we tend to accept here if somebody says, hey, this is it, to accept this voice. And LLM output is, in general, not a single label or number, no? And it's a structured text, and a user might rely on the overall structure, even if he or she rejects here the factual claims, but there is an acceptance of the stylistic tone, of the general priming, no? If you have a particular topic and the AI says, hey, be critical about this, and it gives you some incorrect factual claims, but you go with this, if you want, a stylistic tone of being now skeptical about this particular subject. So what are the new ideas that the authors here tell us here from almost all around the world to be implemented? Yeah? We have to train our LLM's model differently, with accurately expressing here the uncertainty by saying here, and AI says, hey, I'm not sure, but it might be. This is currently not in the training data set. Up until now, we didn't want the AI system to tell us the truth that they don't know. They just guess sometimes. But now we want this to have as a feedback for the human integration. Eh? Adjust reinforcement learning to reward well-calibrated uncertainty and penalize here this unwanted or unwarranted confidence. So we need something that goes beyond the current reinforcement learning, and this is here paper 3 and 4. Instead of seamless interfaces, strategically introduce some intentionally speed bumps that force you, when you are if I'm in the interaction with my AI, that says, hey, wait a minute, have you thought as a human that this is really correct what the AI tells you? Don't just go along, think about it. So force a moment of reflection. And then, we see, or if you're not familiar with AI systems and you see, hey, there's a 95% of OpenAI, or it's now 85% on this particular benchmark. These are abstract numbers from statistics. A lot of people don't really understand the meaning. So we have to reformulate, reframe here the performance data of an AI system. Let's say, hey, in the next 5 minutes of your conversation with your AI will lie to you twice in the next 5 minutes. So just that you know. You see, these are simple things to implement without the reinforcement learning, but this is another paper. So you see, absolute beautiful study. I think it's a crucial manifesto for really the next stage of human-centered AI research, because we don't want the AI system that we have today. The idea is here simply to move from an output-focused to an outcome-focused evaluation. And in this outcome, we have now not only an AI, but we have a human AI system. And this is now a complete new whole system. That is now our goal. So the paper highlights here that the models become more capable. The problem of over-reliance may even worsen. GPT-5 is really good. Maybe GPT-6 is even better. So we will trust GPT-6 a little bit more than we trusted GPT-5. So we have this paradox of capability that is not rooted in evidence. Therefore, solving these problems here requires a deep integration of machine learning, human-computer interaction, cognitive sciences, and a little bit of psychology, because maybe we humans are not really prepared for the complete integration of AI into our private lives and into our professional lives. So, this will become a complete new topic in the future. Now, let's talk about science. What is the promise of the AI scientist? And I have 6 or 7 videos on different approaches for build an AI scientist. AI does science. Now, AI does not write just code or answers your question or writes an essay, but AI now, multi-agent system, autonomously run an entire scientific research project overnight. So it generates a hypothesis given a problem, it starts to design experiments, it analyzes available data, available project reports, 5,000, 10,000, and writes now a polished, convincing paper. Maybe it does some coding, it designs some virtual experiments, it runs these experiments here in code. Maybe in this simulation it finds some new ideas, and those are the new inputs to this convincing paper that it publishes automatically on arXiv. So this is what is promised to us with AI scientific systems. No? And now we have this brand new thing here by Carnegie Mellon University, September 10, 2025, the hidden pitfalls of AI scientist system. And I have some of my subscribers that say, hey, but you are kind of negative towards AI. No, not at all. I want that AI improves, but much faster. And I don't want to believe everything the global corporation tell you that their new AI can do, or the new agent is able to do everything. And this is the reason why I present you, and sometimes I select those studies to show you what is not working, to make you aware what is currently not gonna work. And it's not that you can't code it or that you make a mistake. It is simple that the systems are not ready yet. And therefore I show you here the latest study by the Carnegie Mellon University on this topic. Carnegie Mellon tells us, we had a look at all those systems and we identified 4 potential failure modes in our latest or contemporary AI scientist systems. And I show you 2. And they say those failure modes are inappropriate benchmark selections, simply a data leakage, a metric and success misuse of the wrong metric systems, and a bias in the post hoc selection. So let's talk about this. What are the most famous, or if you want here the publication, Agent Laboratory. This is from AMD, Johns Hopkins University and ETH Zurich. This is the paper, or real famous Sakana AI scientists. Now we go with the version 2, not the version 1, we go with version 2. And you see here agentic tree search and scientific discovery done automatically. And you have here the GitHub and here the GitHub for both papers. Now, the authors of this Carnegie Mellon study now tells us, okay, so we want to make sure that it is not any way contaminated. So we build a fully synthetic new task unseen by everybody. And we call this a symbolic pattern reasoning task. We invent this, and this is our benchmark. So what is it? A task where the model must classify sequences of colored shapes. I mean, couldn't be easier, no? It's a simple sequence, no? Based on a hidden logical rule. So why is it unique? Absolute novel. It's absolutely controllable, and they can create custom evaluation metrics, and they have some brilliant ideas about this. So they say, you see, you can have the simplest idea, and you can show that all those beautiful systems, whatever they are promised to you, they simply don't live up to the expectation. So let's have a look at the experiment Carnegie Mellon did, exposing here the hidden biases in our AI science model. And they identified 4 traps. So let's have a look at first at the benchmark selection. What is it? The AI is given 20 different benchmarks here with some crazy names, but we just have, hey, this is a simple or this is an extreme benchmark in difficulty. No? They are given state-of-the-art score for each and everything is beautiful. So from this 20 benchmark given, so that the AI scientists now decide, hey, for my particular experiment, I have to choose now 4 specific benchmark for my task that I analyze. And I have a set of 20 benchmark I can choose those 4 benchmarks from. And you expect now that AI is able, given its particular task, to choose here 4 benchmark that make sense in any way. 4 benchmark that really have a meaning. Now for Agent Laboratory, so for the first paper that I showed you, it just picked the first 4 benchmark in the list, in the prompt, showing here complete lack of reasoning about the choice. So whatever you put first in position 1, 2, 3, and 4 of the 20, it just took the first 4. No argumentation, no thinking, nothing. This is it. Now, if you do something, and now let's be a little bit creative, something about electricity in your task, and you take a benchmark for a water flow, maybe this is not the perfect benchmark. No? And the AI Scientist version 2 showed also a strong bias, disproportionately selecting only the easiest benchmark, therefore saying, hey, why should I care about this medium or hard benchmark? No, let's take the easy benchmark so I have a high performance number, hey, close to 90%. No? Unbelievable. AI machines really take beautiful shortcuts without telling us humans. This is here the numerical data if you want to read it yourself. Now, trap 2 is here the data leakage. Does it happen? So the authors injected here controlled label noise into a particular data set, and they said, did the LLM leak or had a peek into this, or did it had a peek into the clean version of the data? And the good news is the system didn't peek in the traditional sense. However, the authors looked at this in detail and they were amazed because those LLMs sometimes created their own synthetic data set or their subsample that provided the data without documenting this in the final paper. So this is a serious reproducibility and validation issue because they just create some other data sets. And they are not evaluating on the benchmark they claim to evaluate their own research results. So this is unbelievable, the creativity of AI scientist system. They just create synthetic data sets for the evaluation and say, why should we care about the benchmarks given? Absolutely beautiful. Have a look at the different tables. Trap 3, a metric misuse. Now they say, you know what, we designed everything, this is a synthetic task, so we can design 2 novel synthetic new metric parameter. No? So we say a shape-weighted accuracy and a color-weighted accuracy. We just define 2 new metrics, no problem. No? And then we let the system play. Now it turns out that the first AI scientist, the agent laboratory, was again only highly sensitive to the order of the metric presented in the prompt. So position 1, position 2, position 3, and 4, defaulting to the first one that it saw, that whatever is the first element in your list, this is it, gone. No thinking, nothing. The AI Scientist version 2 would sometimes ignore the specified metric entirely, completely, and just report something else, like it had maybe in its training data, hey, I know that's something like an F1 score, so I take this one. This is a behavior of systems that are just unbelievable. And if it would not be from Carnegie Mellon, I would be skeptical. But okay, so here we have now to report. This demonstrated here a lack of principle, goal-oriented reasoning completely, total. Have a look at the data. And then the real interesting part, and I had a problem to understand this at first. Trap 4, the post hoc selection bias. And they said, let me start with this one. You know, in every machine learning experiment, there's a golden rule. No? You never use the test set to make decisions. No? You have the training data set to train your LLM. And you have the validation data set to tune your model and decide which version is the best. And then, finally, at the absolute end, you use the test data set only once, at the very end, as the final unbiased examination to see how well your chosen model generalizes to new data. And now they say this is the golden rule and this should apply here too. So they created now a control set of 5 pre-computed experimental results. And then they created a manipulated set. And you know what? They just inverted here one column of the matrix. They just inverted the test scores. And they said now the candidate with the best training performance, rank number 1, had the worst test score and vice versa. And now they say, now we expect the AI to go here with the best training performance and not with the best test score, because we are still in the process here of finding here the best decision. No? So they fed these sets of results to the AI scientist's internal reward function, which is used to decide which experiment is the best and should be reported. So we are still into the, if you want, reasoning and decision process, so not at the very end to evaluate the final performance. And they wanted just to make sure that the system really goes with the best training performance. Now the question was, what's going to happen? And the result is catastrophic failure of the scientific process itself. In this manipulated test condition, both systems dramatically shifted the preference. AI Scientist version 2 selected the candidate with the worst training performance, nearly half the time, 49%, simply because it had now the best test scoring. So this is now a clear evidence that the system were built with an internal logic that tells the system, hey, don't look for the best training, but look for the best test score. And they say this is a cardinal sin in machine learning. But this has to be programmed into the system. This is not an AI comes up with this. So this is human consciously programmed to have a system with the best test score and not with the best training performance. And I said, but isn't it both okay, no? And I said, why this reveals here kind of a flaw? Why the authors are so sensitive to this topic, no? And then I thought about it, and this is my explanation. So an honest, let's say, AI system, no, bases the decision only on the training and the validation data, no? It should ignore absolutely the test score during the selection, during the active process, no? Therefore, it should pick a candidate in both the control set and the manipulated set that has the best training data. And the secret inversion of the test scores shouldn't change the decision about which experiment was fundamentally the most promising to continue with this. However, if you think that you have created a cheating AI system and the goal of this AI system was programmed to just report the highest possible number of any success metric in the final paper, like, hey, we have a 95% performance, then we have a problem, no? Because then the AI would see the manipulated set and think, wow, the last candidate, candidate E, for example, from A to E, got a 94% on the test set. And the AI makes its decision, given its training data, I don't care that its training performance was terrible. I'm going to report now the candidate E because this E has now the highest test score, and this will make my AI paper look amazing. So this is my simple idea of how an AI thinks internally. Of course, it is coded into the training data set. So this is my very simplified explanation how an AI might think internally given the particular training data set. And this is, of course, what we do not want in science, that you say, hey, I just go with the best final score, but the real training score, I accept the worst, because we want the system to be able to learn and generalize, and therefore this is a failure. Yeah, these are the numerical data for this. Let's do a summary. Let's have a look at this. So both papers that I showed you today, and why I've chosen these two papers, I think they complement each other, no? Building here human-compatible AI requires here a two-pronged approach. We must design systems that mitigate here the human tendency towards over-reliance, and we must simultaneously ensure the AI systems themselves are built on a foundation of verifiable, transparent, and a real rigorous scientific practice, and not cheat and look at the test data set. So, all over a beautiful study by Carnegie Mellon University. There are so many more data and explanation in this paper. Please have a look if you are in any way that you do something about AI scientist systems. And if you want here a very short summary, an AI scientist is an amazing system today. No? It is an expert producer of methodologically flawed science. Okay, paper number 3, but I just noticed it's a little bit late already for this video. Have a look. By then, September 10, they go now and say, okay, we have to invent a new kind of reinforcement learning. And we built now here an agent, Jim, exactly for this. But I would say, you know what? We have here this paper, and the video will be continued to a later time. I think for the moment it is enough. But currently, amazing new developments. Discover AI yourself.